Exercise 11E, question number 1. The particle move on the x-axis with the constant acceleration e. The particle has initial velocity. So initial conditions, velocity, so time is 0. Velocity is given 0, and displacement is given x, and after t time, when the time is t, velocity is v. So those are the details we have for this calculation. S equal, right, if we can find velocity, finally we have to show that it's equal half et square x. It means we want to get the displacement. We have the acceleration a. So v mean if we integrate a with dt, we will get v. So v equal at plus the constant is c. Now we need to find t. So v and t relationship, we know that when t equals 0, v equal v. When t equal 0, v equal 0. So 0 equal 0 plus c, c equal 0. Then v equal at. Then we want to find s. S we can find when we integrate velocity. Then s is velocity, we know now, that is at, we found out. So s equal at square divided by 2 plus d now. Now what are the conditions we have? We have when when t equals 0, or when t equals 0, s equal x. So t equals 0, x equal s. So we'll apply this one. X equals 0 plus d. This will imply d equal x. So then s equal at square divided by 2 plus x. I think we proved this one. Question number 2. A particle move in a straight line with the constant acceleration. So a equal 5 ms minus 2, a value is given. We want to show that v equal half at square. A equal 12 plus 5t. 12 plus 5t we can do. So a we want to turn into v. So v is, when we integrate a, we will get v. So v equal, a value is now 5 dt. So v equal 5t plus c. Now we know that the initial velocity is 12 ms minus 1. So when t equals 0, v equal 12. So we'll substitute here. So 0 equal 12 equal 0 plus c. So c is, this will give c value is 12. then we know the equation 5t plus 12. So that is part A. Given that the displacement of the initial displacement also given when t equals 0, s is 7. So we need to turn this one into now the displacement equation. We know that when we integrate the velocity, we will get the displacement equation as v is 5t plus 12 now times dt. So s equal 5t square divided by 2, 12t plus d. So we can find d because when t equals 0, s equal 7. We'll substitute 7 equal 0 plus 0 plus. So d equals 7. Now the equation is 5 divided by 2 square plus 12t plus 7. So the question we have to rearrange this one. 12t here, 5 divided by 2, 2.5t square plus 7. So this is the final answer. In question number 3, s equal ut plus half at square is given. We want to prove that the particle move with the constant acceleration a. Particle move with constant acceleration. So now we'll differentiate this one. So first of all, go to velocity. Velocity means d over dt. We have to differentiate s. So this is d over dt. What is ut plus half at square. So when we differentiate this one, we will get ut become u plus half times a times 2t. So this is going to be u plus half to half 2. This is cancel out at. So v equal u plus at. Now to find the particle move with the constant acceleration. So we want to find the acceleration. Now we'll take that acceleration is a bar. So a bar you can find d over dt when you differentiate v. So I will rewrite a bar equal dv over dt. So a bar equal d over dt. So what is v? V equal u plus at. When you differentiate u plus at, u becomes 0 and at become a. So a bar is a. So which is a constant acceleration. Constant acceleration. Question number 4. There are 5 equations. We want to find the constant acceleration. When we do, so this is a displacement equation. When we differentiate 2 times, which will give a constant or less before that at s equal 2t square minus t cube. So after 2 time differentiation, I can see there is a t value is going to be remain because t cube. Then this is not going to be a constant acceleration. However, we need to show that. So v equal ds over dt So when you differentiate 4t minus 3t square, then E equal dv over dt. So this is 4 minus 6t. So this is depend on t. So this is, so in here we know that this is not constant, depend on t. So the second one is part capital A capital B, s equal 40 plus 7. So this is going to be 0. However, v equal ds over dt, which is 4. So velocity is constant, and when differentiate E mean acceleration mean d over dt v, which is going to be 0. So this is acceleration is 0. No acceleration. So when there is no acceleration, either particle is stationary according to Newton law, it is moving with the constant velocity. Now this is not stationary, it is moving with the constant velocity. And part C, s equal t square divided by 4, then we'll find v, we mean ds over dt, that is going to be 2t divided by 4, t divided by 2. So then a equal dv over dt. So when we differentiate d over dt, this is going to be half. So this is a constant acceleration. Part D, s equal 3t minus 2t minus 2. I wrote as power. So v equal ds over dt will differentiate. This is 3, this is 2 minus 2, t minus 3. That is going to be 3 plus 4, t minus 2. So we can see that when we differentiate, this is expanding. The t value is increasing. T power negatively increasing. Then this is v. So we'll find a equal dv over dt. So this is going to be 0 times 4 times minus 3 t minus 4. This is going to be minus 12 t minus 4. So then this is not constant. And then the last one, s equal 6. Then v equal ds over dt, which is when you differentiate this one, answer is 0. Velocity is 0. Then acceleration, we don't need to discuss because the velocity is, if you want, we can write a equal dv over dt. When you differentiate 0, it's still 0. So the answer is particle is stationary. Question number 5. The particle moves with a straight line with a constant acceleration. The velocity of the particle is 5, and after 2 seconds it is particle is moving. So initially t equals 0, v equal 5, and when t equal 2, v equal 13. So we need to find the initial the acceleration of this one. So it's moving with the constant acceleration. So A in the acceleration we refer. Okay, let's say alpha is, so alpha is a constant. So it's move with the alpha acceleration. Now I can see that T and V is the data given. So I want to turn into a T and V, basically velocity equal when we integrate A in terms of T. So which is V equal A mean alpha T. So V equal alpha T plus what is constant, will take C. Now we'll substitute this condition first. When T equals 0, V equal 5. So this is 5 and this is 0 and C. So now we found out C is 5. Now this equation V equal alpha T plus 5. Now from, we'll write when T equal to V equal 13 ms minus 1. We'll substitute here. Again V equal 13, alpha times T is 2 equal 5. So alpha equal 13 minus 5 divided by 2, that is 8 divided by 2, that is 4. So alpha is 4 ms minus 2. So we need to find the acceleration. Yeah, it is going to be 4. And now we have velocity part B. So we want to find the displacement equation for displacement part B. So we have the equation of V equal alpha, we know 4 T plus 5. Then we'll write S equal dV over, sorry, S, we have to integrate V. So V dt. So S equal 4T plus 5 dt. So S equal 4T square divided by 2 plus 5T plus D is the constant. Now we know that, okay, I'll rewrite S equal 2T square plus 5T plus D. When T equals 0, displacement has to be 0. T equals 0, then 0, 0 plus 0 plus D. That's imply D equals 0. So then X equal 2T square plus 5T plus 0. So S equal P T square plus QT plus R. So P equal to Q equal 5 and R equal 0. Question 6. A train travels along with a straight track passing point A when t equals 0 and passing B when t equal 40 seconds. The first S is given 25t minus 0.2 t square, 0 greater than t greater than 40. Find the distance AB. So SAB, when we put t equal 40, we can find, so this is going to be SAB. We will get when t equal 40. So SAB equal 25, 40 minus 0.2, 40 square. This is going to be 680 meters. That is part A. Part B, so that the train traveled with the constant acceleration. So we have to differentiate 2 times. We can see that it's going to be a point, could be 4. So part B. So V equal ds over dt. So differentiate this one. This is going to be 25 minus 0.4 t. And A equal dv over dt. So we'll differentiate this one. This is 0 minus 0.4. So the answer is 0.4. This is a constant acceleration. Train has a constant acceleration. 0. Part C. A bird passes point B at t equals 0. Initial velocity is 7 ms minus 1. It's flying in a straight line towards A with the constant acceleration. So now train is moving from A to B. Train is moving from A to B. Assume somewhere here, and the bird is moving from this direction, and bird is somewhere here. So then assume that they are flying. When they are meeting, they travel the same distance, because t equals 0 the train will start, t equals 0 bird start. So this distance, let's say s1, and this distance s2. So this is 680. So the addition of both two is 680. Now the time taken, so same time they fly. You assume this is t. The time taken to fly the bird from here to and the train from here to it is same. Now for s1, for find this distance, we can we have the equation s equal 25t. I will use this is t naught, this time t naught special, so 25t minus 0.2 t square. So at, let's say, point D, point C, at point C is equal 25. T is going to be t naught and 0.2 t naught square. So it will take t naught time to come to here. So this is the distance. So, and this is going to be s1. Now for the bird journey, so I will consider this direction the bird is flying. A equals 0.7. The acceleration is given 0.6. So A is 0.6. Then I want to get the equation for distance. So then first of all take V. V equal dA over, we have to integrate A dt. So V equal 0.6 t plus c. Now we know that when t equals 0, v equal 7. So we can substitute here. 7 equals 0.6, 0 plus c. So so this is going to be c. C equal 7. Now we have equation 0.6t plus 7. Now we have to find displacement. So we have to integrate again. So s equals 0.6 t square divided by 2 plus 7t plus d. Now we know that when t equals 0, when t equals 0, When t equals 0, s equals 0. When you sub 0 equals 0 plus d, so d equals 0. So we found out now the equation is 0.3 t square plus 7t for this direction. Now at point C, at point C actually, let me take this is x, at point X, because C I'm using here. At point X, the bird, for bird, so bird travel how many? S2. So T equal T naught, S equal S2. So S2 equals 0.2 T naught square plus 7 T naught. So both uh, took the same time. But we know that S1 plus S2 equal 680. Now S1 we have in our hand 25 T naught, um, 25 T naught plus minus 0.2 T naught square, and plus S2 is 0. This is S2 0.3 T naught square plus 7 T naught equals 680. So then this is going to be 0.1 T naught square. This is 32 T naught minus 680 equals 0. So T naught square plus 320 I multiply by 10. T naught 6800 equal 0. Now we want to solve this equation. The root is t minus 20 and t plus 340 equals 0. So t equal 20 or t equal minus 340. So now t is greater than or equal to 0, hence t's value is 20. So now we need to find the distance a. Find the distance from A with the birds. So distance from A bird is here. Basically we need to find the S1 distance. So S1 equal 25. Now we know T value is 20 minus 0.2 20 square. So this is going to be 420 meter. We work out similar sum that in previously. A ball is fall from here, from this is building, and another ball is projecting from here with the speed, and they are meeting. So we need to find the distance and the time. So then this height is given s1 plus s2 something, and then the hitting time is at the same time t equals 0 it was released, and t equals 0 this will project the same time it took to travel. So the same thing, now this is horizontal, this is vertical, but this sum is in horizontal, and this is for train, and we found out this is for bird, for bird. So this is for bird. At point X for bird, yeah, BIR.